There we go. Okay, so our I can statement. I can solve systems of linear equations. Some of you guys were smart and already wrote it out when you were starting. I saw that. I can solve systems of linear equations using elimination, comma, specifically systems with equations that require multiplication to create coefficients that are opposites. So we're going to have to do some multiplying. We're going to have to do some multiplying. Now the steps for solving do not change. We're going to use the same exact method. We're going to figure out what we have to multiply that equation by so we can cancel out either the x's or the y's. We cancel them out by adding them together, and then we solve for that variable that's left and then plug it back in, okay? So I can solve systems of linear equations using elimination, specifically systems with equations that require multiplication to create coefficients that are opposites. Okay, guys, I want you to pick your heads up. We're not laying our heads on our desk. All right, so step number 1, make sure your equations are written in standard form. Step number 2, line up the x's and the y's. Same thing that we did yesterday. Step number 3, this is different. You might have to multiply one or both equations by numbers that produce opposite coefficients. So let's look at this system right here. We're going to look at this system. If I wanted to get rid of the x's, if I wanted to eliminate the x's, what could I multiply the two equations by? What could I multiply the two equations by? I want to get opposite, same number but opposites. So I'm trying to get rid of the x's. So what could I multiply these by to get rid of the x's? -1 won't work. What's a number that 4 and 5 both go into? 20. 4 times what gives me 20? 4 times 5. And you see that this is already a negative and this is a positive. So if I multiply by a 5 in the top equation and a 4 in the bottom equation, what am I going to end up with? Well, let's see. 5 times -4 is -20x. 5 times 5 is 25. So that gives me 25y. And 5 times 8 is 40. The bottom equation, 4 times 5x is a positive 20x. 4 times -8 is a -32. So that gives me -32y. And 4 times -3 is -12. So it says, note, we can multiply the top equation by 5 and the bottom equation by 4 to eliminate the x's. But what if I didn't want to eliminate the x's? What if I wanted to get rid of the y's? What if I wanted to cancel out the y's? What's the number that 5 and 8 both go into? 40. 5 times what is 40? 5 times 8 is 40. 8 times what is 40? 8 times 5. So let's see what happens there. So 8 times negative 4 is negative 32. So I have negative 32x. 8 times 5, that's a positive 40. So I have 40y. And 8 times 8 is 64. Okay. What about the bottom equation? 5 times 5, that's 25. So I have 25x. 5 times negative 8 is negative 40. So I have negative 40y equals, let's see, 5 times negative 3 is negative 15. So we can multiply the top equation by 8 and the bottom equation by 5 to eliminate the y's. So the reason that these are more challenging is because you have to make a choice. Do you want to eliminate the x's? Do you want to eliminate the y's? Which one's going to be easier? Sometimes you only have to multiply one equation, right, to eliminate a variable instead of multiplying both. So same principle, you add the equations together and eliminate one of the variables. So I've kind of done the work for you here. So it looks like we're going to eliminate our x's. So our first step, we are multiplying the top equation by 5, and we are multiplying the bottom equation by 4. We're distributing that through to every single term. When I do that, I end up with negative 20x and a positive 20x. These are opposite, right? Same number, but opposite. So we know that those are going to cancel out. We know those are going to cancel out. We have to add the rest of this together. I want you guys to know that on your copy, this says 7x. Do you guys see that? Negative 7x, or maybe just says x equals. Look right here. What does it say in your copy? Can you change that to a negative 7y? Pay attention to what I'm saying. It is negative 7y. Divide both sides by negative 7. That means y equals negative 4. Your copy says x. Fix that. Your copy says x. You need to fix that. Tyler, are you taking notes? Okay. So what do we do with this? Now that y equals negative 4, what do we do? Which one? You said bottom? Okay. Aiden wants to plug it into the bottom equation. Are you guys okay with that? I'm okay with that. We just have to make sure that we plug it into the original, not one of the ones that we changed or altered. So the bottom equation, 5x minus 8y equals negative 3. Well, we know that y is negative 4. So let's rewrite this. 5x minus 8 times y is negative 4 equals negative 3. What is negative 8 and negative 4 when I multiply those together? A positive 32. So 5x plus 32 equals negative 3. Aiden, what would you do next if you were working this? Subtract 32 from both sides. That sounds excellent. So 5x equals negative 35. Divide both sides by, and x equals, are we all finished? What do we need to do? Ordered pair. Remember that this is an x, comma, y ordered pair. So what is my solution? Negative 7, comma, negative 4. Perfect. Negative 7, comma, negative 4. Okay. Are we good with that? Does anyone need more time? Isaac, you got it? Okay. All right. So let's go to number 1. What do you think is going to be easier, to get rid of the x's or get rid of the y's? It's a personal choice. If we wanted to get rid of the x's, what could we multiply by? If we wanted to get rid of the x's, If you wanted to get rid of the x's, is there something that I can multiply this number by so that it is the same as this but the opposite? I could multiply the top equation by -2. That would help me eliminate the x's. Okay? What if I wanted to get rid of the y's? What number can I multiply this whole equation by that is going to give me the same number but the opposite? The bottom number is a -7. What's the opposite of that? A +7. So if I wanted to eliminate the y's, I'm just going to write a little note over here. I could multiply the top by 7 and eliminate the y's. But we're not going to. We're going to keep up with that first idea of multiplying by -2. So that means that every single term in the top equation is getting multiplied by -2. Let's see. 5x times -2 is -10x. Y times -2 is -2y. 9 times -2 is -18. The bottom equation does not change. It's the same thing as multiplying by 1. It just doesn't change. So 10x minus 7y equals -18. Now remember that we are adding these two equations together. And I don't know why, but sometimes you guys look at that -18, -18, and you're like, oh, they cancel each other out. But they don't. Remember, we're adding these together. So the -10x and the +10x cancel each other out. A -2y plus a -7y gives me a -9y. Good. A -18 plus a -18 gives me -36. Divide both sides by -9. And I find out that y equals 4. Okay, what equation do you want to use? Do you want to use the top equation or the bottom equation? Yeah, let's use the top equation. So 5x plus y equals 9. And I'm taking the fact that y equals 4. So I am going to sub in y equals 4. So let's see. 5x plus, what is the value of y? 4 equals 9. What do you want to do now? Trying to solve this. Yeah, we're going to subtract 4 from both sides. So 5x equals 5. Divide both sides by 5, and I find out that x equals 1. Am I done? No, what do I need to do? Write my solution as an xy ordered pair. 1, 4. 1, 4. Are we ready to move on? Anyone need more time? Good. Okay. Next one. Number 2. So what do you think is going to be easiest to get rid of the x's or the y's? It's your choice. The y. Okay. If you want to get rid of the y, what would you multiply by? Say it again, Aiden. If I multiply the bottom equation by -3, I'm going to end up with just a regular 3. Yeah, good job. I'm going to multiply the bottom equation by 3. Top equation, I'm not changing it all. So this is going to let me eliminate my y's. Okay. So the top equation, I write a 1 there so I know that I'm multiplying both equations by something, but we're really not changing it, right? So the top equation doesn't change. Negative 4x plus 9y equals 9. The bottom equation, however, let's see. 3 times x is 3x. 3 times negative 3y is negative 9y. And 3 times negative 6 is negative 18. So remember, I'm going to add these two equations together. My y's are actually the same coefficient but opposite, so I know that they will cancel out. So I need to have the same number, the same coefficient, but they have to be opposites. That's how I know I can cancel those out when I add them together. So now I have negative 4x plus 3y. Well, that gives me a negative 1x. And 9 and negative 18 give me negative 9. Divide both sides by negative 1. X equals positive 9. Daniel, what do you want to do with that x equals positive 9? Do you want to put it in the top equation or the bottom equation? I totally agree. I would put it in the bottom equation too because it has a coefficient of 1. So I'm going to rewrite the bottom equation. X minus 3y equals negative 6. And I'm going to sub in x equals 9. So let's see. Instead of the x, I'm going to just put a 9 there. Instead of that x, I'm just going to replace it with a 9. 9 minus 3y equals negative 6. Lysandra, what would you do to solve this? What would you do next?
9 for 1.
We subbed in 9 for the x, right? We've already done that. So now I'm just trying to solve for y. What would I do? Subtract 9 from both sides, right? Subtract 9 from both sides. Remember with equations, whatever you guys do on one side, you have to do on the other. Whatever you do on one side, you have to do on the other. So I have negative 3y equals, let's see, negative 6 and negative 9 give me a negative 15. Daniel, what would you do next?
Divide by negative.
Divide both sides by negative 3. I find out that y equals 5. Ken, what is my solution? What is my solution? It's an ordered pair. What is it? X comes first. 9, comma 5. We got to remember that our ordered pairs are XY ordered pairs. They're in ABC order. Guys, pick your heads up off that table or you're going to both stand. Thank you. Let's look at example number 2. Or that was number 2. Example number 3. Does anyone need more time with this? Okay, let's go to example number 3. Okay. Brianna, do you want to get rid of the X's or the Y's first? Make a choice. Just X's. Okay. So Brianna wants to get rid of the X's. So let's look at the coefficients. I've got a negative 4 and a negative 1. What can I multiply by to get rid of those? Make them the same number, but opposites. Negative what? 4. Negative 4. Daniel says we're going to multiply that bottom equation by negative 4. And I totally agree. I think that's perfect. So, not changing the top equation at all. So my top equation stays the same. Negative 4x minus 15y equals negative 17. My bottom equation, however, negative 4 times negative x gives me a positive 4x. Negative 4 times 5y gives me, anyone? Negative 20y. And negative 4 times negative 13 gives me, anyone? 52. Positive 52. Okay? So remember that we're adding these together. So I have opposite coefficients. They're the same coefficient, but they're opposites. -4, +4. So our x's cancel out. Brianna wanted to cancel out the x's. We've done that. I'm adding these together. So this essentially is -15y plus -20y. What is -15 plus -20? So -35y equals -17 plus 52 is a +35. I'm going to divide both sides by what? And when I do that, I end up with y equals -1. All right, 8 and A. Do you want to plug in or substitute y equals -1 into the top equation or the bottom equation? Totally your choice. Into the top one? So Aiden says we're going to substitute into the top equation. So I rewrite the top equation, the original top equation, not the one that we manipulated by multiplying by. So let's see. I am going to sub in y equals -1. I'm substituting in y equals -1. So let's rewrite that. What's it going to look like? Who can tell me exactly what to write? Owen.
-4 times, parentheses, -1,
Owen. What are we replacing? Are we replacing the x or the y?
the y. So that's -4x minus 15 parentheses, -1.
Awesome.
Equals -17.
Perfect. Excellent job. So what is -15 times -1? It's a +15, right? Yeah, so I have -4x plus 15 equals -17. Avery, what do you want to do next? If you're trying to get this all by, like, get x alone, what would you do next? Say again? That 4 is attached to the x. I can't do anything with it until I get x all by itself. So what's still on that left side? -15. Yeah, we're going to subtract 15 from both sides. Nice job. Okay, so -4x equals -32. All right. Kylie, what would you do next? Divide both sides by, good job, divide both sides by -4. So x equals +8. All right. Isaac, what is my solution? Remember that it is an x, y ordered pair. What is my solution? 8, -1. Perfect. How do we feel about this? Okay. Questions? Okay, so let's look at this word problem. A concession stand is selling a total of, a concession stand sold a total of 138 small and large bags. So that means that whatever we do, whatever we add together is going to equal 138. Do you guys see that? A total of small and large bags. Well, what are we adding together? What is getting added together? Yeah, and that's your question. How many small bags and how many large bags were sold? So I'm going to say X is the number of small bags and Y is the number of large bags. So can you come up with our first equation? If we're selling a total of small and large bags, a total of small and large bags. What variable represents the number of small bags we sold? X. What variable represents the number of large bags we sold? What does it typically mean when it says your total is? Is that an addition problem, a multiplication problem, a subtraction problem? It's typically addition, right? So how do I show that? Add them. We're going to add x plus y equals 138. Different class period, but can you just,
Interesting.
yeah. So let's look at our second equation. A small bag costs $2.50 and a large bag costs $400. And the total amount of money we made in sales is $466.50. So what's that equation going to look like? $250x plus 4y equals 466.50. Perfect. Perfect. Okay, so we have our two equations. Now we need to make a decision. Do you think it's going to be easier to get rid of the x's or the y's? The y's. And I agree. Why do you think it's going to be easier to get rid of the y variable instead of the x variable? It doesn't have a decimal in it. Yeah, absolutely. So what can we multiply our top equation by that will allow us to eliminate the y's? -4. I'm not multiplying the bottom by anything, so I'm just going to write. I'm not changing it at all, so I'm just writing that I multiply by 1. So let's see. -4 times x is? -4 times y is? And -4 times 138 is? -513?
552.
Oh, 552. Thank you. Okay. Are we good? We're not doing anything with the bottom, so I'm just going to rewrite it. 2.5, and I'm going to drop that 0 because I don't need it. 2.5x plus 4y equals positive 466.5. Again, I'm dropping that 0 because I don't need it. So we're going to be able to cancel out the y's. What is -4 plus 2.5? -4 plus 2.5.
-1.5.
So -1.5x equals, what is -552 plus 466.5? -85.5. All right. Tyler, if we're trying to get x all by itself, what would you do next? By? Yeah, absolutely. Good job. We're going to divide both sides by -1.5. So x equals, well, I know a negative divided by a negative is a positive. It's positive what? Positive 57. Okay, that means that we sold 57 bags of small popcorn. Let's figure out how many bags of large popcorn we sold. How many bags of large popcorn did we sell? How are we going to do that? Okay, which equation do you want to plug that into, Aiden? Do you want to plug it into the top equation or the bottom equation? Yeah, let's plug it into the top equation. So I'm going to take this x equals 57, and I'm going to plug it into my top equation, which is x plus y equals 138. So I'm going to sub in x equals 57. Substitute in x equals 57. So 57 plus y equals 138. What should I do next, Victoria? Trying to get y all by itself. Yeah, we're going to subtract 57 from both sides. So y equals 81. So we sold 57 bags of small popcorn. I said that really weird. And 81 bags of large popcorn. I'm still going to write my solution as an ordered pair, 57, 81, but I need to give a word statement. Why? Why is that important? Did you have any? Owen, you know why?
No, I wasn't raising.
Oh, okay. What kind of a problem is this? It's a word problem. So when we have a word problem, we need to give a word answer. Word problem.